My name is Alex Nusha Jafari, and I'm here with Irfan. Irfan, do you want to say hi?
Hi, Nusha. Good afternoon. How's it going?
It's going really well. I'm excited because we're going to do the homework problems together. Once again, this is from AP Computer Science Done Right. It's a book that systematically teaches you how to program in Java, but it also just teaches you how to program overall. And after this, you can, essentially program in any language, not just in Java. It's only available on Amazon if you'd like to purchase the book, and you can have it either as an ebook or a hard copy. And today we're going to go over Chapter 2, Section 2 homework, which was tying classes together. Now, if you're ready, Irfan, let's go through the homework problem and see what we have to do.
Let's go.
Excellent. So it's a very exciting homework. It says you're designing a theme park with different activities and roller coasters. The activities include jet skiing on a chocolate lake, bungee jumping with koalas, high speed gossip trail, and many more. All activities are either liquid based, free solo rides, or roller coasters. Design an interface and a set of classes that represent information about your theme park. Okay, are we ready?
We're so ready.
Excellent. So, first things first, we know that our job, our true purpose in life, is to represent information as data. And when something is complex, we want to represent it as classes. Now, what classes would you say we probably need to represent this information?
I would say that since there are three complex activities and they have their own information, we have to represent liquid based, free solar rides, and roller coasters in three different classes.
Okay, great. So we have liquid based, free solo ride, and roller coasters. Excellent. So we have three classes per each. Okay, what else? Do we need anything else?
And I think, as we learned in the previous lesson, we'll need an interface for the common information between these classes.
Excellent. So we would probably have an interface, theme park interface, or theme park activity interface. Um, okay. How would we tie it? How would we make sure all three classes are tied together with that interface?
We just need to use the keyword implements, I think.
Excellent. Yes. So we would implement the interface in those three. Excellent. Anything else do we need?
Mm, I don't think so.
All right, let's get started. Are you ready?
Yes, let's go.
Okay, we learned that each new class should be a new file. So we'll go back to the source and we'll create a new class. That would be liquid based activity. All right. And actually, let's first start with the interface. Are you ready for that?
Yes, I'm so ready.
Okay. So we can call it an interface. And what kind of interface did we say it's going to be?
Sorry, could you repeat?
What should the name of the interface be?
It can be theme park activity.
Theme park activity. And remember, we just start with an I to remember that it's going to be an interface.
Okay, yes.
So I theme park activity. Excellent. Great. So now when we go back to the liquid base, we can use the magic word that you said. What should we write?
Implement.
Yes, implement. And it should implement the I theme park activity. So far, so good?
So far, so good.
Excellent. And then we can create a similar thing for the other interface, the other classes. What information should there exist in a liquid-based activity?
So the activity has a name, obviously.
Of course.
So it will be a string name.
Great.
And in the question, they said that it has an insurance fee. And that's going to...
Wait, stop. That's the second homework problem. Let's go back to the first.
Okay.
Oh, sorry. No. Yeah, no. Yeah, it's in the second problem, not in the first one. So we don't have to worry about that first.
Okay.
Yeah. Okay. All right. So an activity will have a name, essentially, right? That's all we know about activities so far.
Exactly.
Excellent. And how do we create a new type of a liquid-based activity or anything else?
Do we need to create a constructor for it?
Exactly. So we can create a constructor. We've learned this already, so we'll have IntelliJ just create it for us.
Sorry, could you do that again? How did you do that?
Absolutely. So I'm just pressing Command N on a laptop, but all you need to do is just right-click here and do Generate. And when you do Generate, I select a constructor. And it says, okay, would you like to construct it with the field string name? And I say, yes, I do. And voila.
Okay.
We have it. Very easy. Okay, we probably are going to have a name for all the other activities as well, right?
Right, yes.
Okay, so in that case, what should our interface have?
First of all, a name.
Okay, how do I write this?
A string name.
Okay.
And a semicolon.
Okay. Are you sure about this?
Not quite.
Okay. Remember, last class we said interfaces don't have fields. Interfaces don't know anything. Interfaces are just a contract. They're saying this class that will implement me will definitely have this method. It's a contract for methods. So all we have to do here is define methods that a liquid-based activity has.
All right. So, yes, we need to add parentheses after name. And also, since we don't already have the name, we'll have to write get name instead of just name.
Exactly. It's a better name for it. It doesn't obviously matter what you write, but it's better to say get name because that's what it's doing. Okay. And we already see one related problem. Let's go ahead and see what that problem is. Ooh, can we guess what the problem is?
What is the problem?
So we're saying liquid-based activity implements iTheme Park activity. And an iTheme Park activity is promising to have a get name. So what are we doing here?
We have the name here.
We have a name as a field. We don't have the method get name.
Oh, yeah. So we need to create a method to get the name?
Exactly. We have to fulfill our promise. It doesn't care that we have the information somewhere. It's saying every iTheme Park activity will have a get name method. So we have to create a get name method. And it has to be of type string, right?
Right.
Okay. It has to be the exact same name. If it's just like name of class, let's say, it won't work. It's still complaining. It has to be the same name, so it has to be get name. Does that make sense?
Okay, it makes sense, yes.
Okay, all right. What should I do after?
And then just a semicolon, because you'll get the name.
How do we write methods? What do we do? This is a let me start with a design recipe. This is great because we know why design recipe is important. What's the first thing we do in methods?
We write a purpose statement by the design recipe.
Exactly. Let's write a purpose statement. So, method to retrieve this activity's name. All right. What's the next step?
Okay, we'll have the signature.
And what's the signature?
Yeah, we'll have to start by a string. Excuse me.
Yes, exactly. So string, and what else?
The string gets name, and then a parenthesis.
Yep.
And whatever input we want.
Okay. Do we need any input?
Oh, I think we already have the string name in the class, so we don't need any inputs.
Precisely. We already have the string name. So that can be empty. All right. What are we doing next in the design recipe?
We'll have the example.
We'll have the example. Fantastic. So let's say if we have created a liquid-based activity with name, let's say the liquid-based activity has the name, I don't know, chocolate ball. Then when we call la.getName, it should return chocolate ball, right?
Right, yes.
Okay, what's the next step in the design recipe?
So we start to code, and I think we must use the keyword return here.
Perfect. We'll use the keyword return. And then what do?
Return this.name.
Fantastic. We have a winner. Oh, I don't like that. There we go. All right. Does this make sense?
It all makes sense, yes.
Excellent. Are we done?
We need to test that method.
Exactly. We need to test it as well. Before we do this, though, we are seeing a complaint from IDE. Can you guess what the complaint is?
There is a line under getName. I think it's related to that.
But before, I don't want the IDE to give the answer away, so I don't want to hover over it.
Okay.
Before we do that, so remember, iThemePark is saying I expect every class that implements me to have getName. So I have to have access to the getName method.
So it has to be public.
Exactly. It needs to be public because by definition, it's by default, it's not public. So getName is not known to iThemePark activity. Now we're okay. Now we have public string getName, and iThemePark is happy. It's like, all right, I know we're good. Does that make sense?
Yes, makes sense. So whatever method we're using has to be public for the interface to have access to it.
Exactly. We can have private methods. We can have methods that, we just need internally. But if it's a method that we have promised the interface to have, it needs to be public so that everyone can have access to it. All right, let's go back to the testing. So remember, I do a generate of a test. And I want to test getName. So I can just test it here. So for example, I can have, how do I make create an example of liquid-based activity?
We start by assert equals.
So that's for testing. I first want to make an example of it, then I can create the assert equals.
Okay. So liquid-based activity with name. So let's say, I don't know, chocolate fall it was.
Yeah. Okay.
Gets new liquid-based activity.
That's new liquid-based activity. Okay. And it needs a name, so I'll just pass in chocolate falls. All right. Now how do I test it? You were saying before.
So we'll start by assert equals.
Yep. I'll start with assert equals. And you can say chocolate fall. Whoopsie. Dot get name. And I expect it to be chocolate falls. Does that make sense?
Yes, makes sense.
Perfect. I will run this test. And I'm sure it will pass because we are great programmers. But one thing, we are creating liquid-based activity as a liquid-based activity class. We can also create it as an iTheme Park activity class. Is that right?
Right. We could use implement keyword for that, right?
How do you mean? How would we write it?
So iTheme Park activity. Chocolate fall is the name of it.
We can have
Again?
similar names, so let's say I have Choco Fall. Okay.
Gets new liquid-based activity.
Okay.
And with another name again. Is that right?
It is right. I was just confused because you said we would use the implements keyword. Where would we use the implements keyword?
Oh yes, my mistake.
No worries. Okay, so we don't need to have the implements keyword anymore, right? We already have it in the liquid-based activity. And we can have another example here, or a test, I should say. Assert equals chocofall dot get name. And what do we expect it to be?
To be chocolate fall.
It will be chocofall.
Choco fall, yeah.
Excellent. You can run it, and I'm sure it will pass it. Fantastic. All right. So then now we know that we just need to create the same thing for the other activity types, right?
Right.
And roller coasters, right?
Yes, so we need to create 2 more classes.
Exactly. All right. What are the name of the classes that I'm making?
It would be, the first one would be, let's say roller coasters.
Okay. Whoa. All right. What I do here?
So as like the previous class, you'll have a name. So it will be.
You mean here?
Yes.
Okay. Anything else I need to do? How do I know that the roller coaster is a theme park activity?
How do you know that?
I have to use implements, right?
Okay, yes.
So I have to say implements iTheme Park activity. And then it will complain and it will say, hey, you made me a promise, man. You promised that you would have a get name of it, right?
Right, yes.
So how would I do true to my promise?
So it will be public, since we want the access to it, and public is string name.
Yeah.
Public is string name with parentheses.
Okay. What else?
Get name, excuse me.
Okay. All right. Anything else?
And then we want to return, right?
Yes, exactly. It's still going to be a method, so it has to return. What should it return?
Return this dot name.
This dot name, precisely. All right. How do we create new classes or new instances of a class?
How do we do that?
We create constructors, right?
Okay, yes.
Alrighty. Now this is also abiding by the theme park activity. What's it called? The theme park activity interface, and then we created another class for what is it? Free solo activities, right?
Free solo rights, yes.
Yes. All right. What do I do here?
Exactly as like the two previous ones. So we'll have a implements iTheme park activity.
Yep. Implements iTheme park activity. It will have a name.
Name.
It will have a constructor. And
it will have a get name method.
Yes, exactly. And it'll have to return this down. All right, let's create. Our tests can be from this. So the chocolate lake, bungee jumping, and high-speed hollow, a high-speed gossip train. So how would we create examples of those?
So bungee jumping with koalas.
Mm-hmm.
Just a second, let me see. Okay, so the high-speed gossip train will be in the roller coaster class, this example.
Okay.
And
wait, let me make sure I understand. What do you mean it will be in the roller coaster class?
no, I mean it's a roller coaster activity.
Okay, so it's a roller coaster activity. All right. So how do I make an example that's high speed gossip train?
So we write free solo ride, high speed gossip train gets new solo ride, right?
Let me first make sure that we have all the classes. I feel like we missed one for some reason. So we have a free solo one. We have a liquid base. I don't think somehow our roller coaster activity. Oh, there we go. It's here. All right. Okay. Where am I creating this example? Where should I go?
In the main class, I think.
Okay. In the main class, what should I write?
Free. What was it called? Free solo ride.
Free solo ride. Okay.
And the name of it, high speed gossip train, let's say.
Okay. So just so you know, actually, a high-speed gossip train is a roller coaster.
Oh, sorry.
Yeah, no worries. Free solo ride would be bungee jumping with koalas.
Oh, okay. So bungee jumping with koalas.
Okay. I'm just gonna call it bungee jumping. All right.
Gets new free solo ride.
Okay.
And bungee jumping again here.
Bungee jumping with koalas. Okay.
And we also need to. What do we do here?
So the reason why we don't really know what to do here is that this is in the main class. It should be in the testing class. So I can copy this, or I guess I can cut this. So in our free solo ride class, we should create a test for get name, let's say. And we want to test get name method. We can create an example of this. And here we can just test it with the assert equals that we know and love. That would just be bungee jumping dot get name, right?
Right, yes.
Capitalization matters. And then once again, you can always do an iTheme park activity. Bungee jump gets a new free solo ride.
What is the point of testing this iTheme park activity here?
Because we want to make sure that the dynamic dispatch here is working correctly, and it's working the same as it would for a free solo ride.
Okay, so it's about the dynamic dispatch.
Yes. Because remember, essentially, eventually, we're gonna just use iTheme park activity instead.
Mm-hmm.
Oh, I forgot the assert equals. That would be bungee jumping. And essentially, we can have the same tests for Chocolate Lake and high-speed gossip train. Does that make sense?
Exactly, yes.
Okay, great. So one thing that's really important to realize is that we identified correctly the three types of classes. So liquid-based, free solo, and roller coaster. Examples of those classes should not be a class in their own. They should simply be an example instances of those classes. So they can just be just like this. They don't need to be their whole class of like bungee jumping. There's no whole class of jet skiing. That's an example of a category. But a class needs to be a category which is a free solo ride or a liquid-based activity or a roller coaster. So far, so good?
So far, so good. Makes sense.
Excellent. Let's move on to the next problem set. It says the insurance in each of the theme park activities is very different based on their type. For liquid-based activities, there's a flat fee per ride. For free solo rides, it's a fear factor times insurance fee, and a roller coaster is a max number of people times insurance fee. So let's design a method that will return a theme park's insurance cost. So first up, we're saying we need to design a method for every theme park activity. It should have an insurance cost. So first, let's go to their theme park activity. All right. What should we add here? So besides name, we are promising every theme park activity to have an insurance cost. So what should we add here?
So we can say that it's an int because it's a whole number.
Yes.
And let's call it insurance cost.
It's essentially get insurance cost, right?
Get insurance cost, yes. Since it's a method, yes.
Excellent. Anything else? Anything inside?
And a semicolon.
So as we can see, there's no logic inside of this. This, once again, an interface is just a promise. It's just a contract saying, hey, I promise every iTheme park activity to have an insurance cost method. Does that make sense?
Yes, so we'll need to give an insurance cost to each of the classes.
Exactly. We have three related problems, and sure enough, it's the three classes that implement iTheme park activity that currently don't have an insurance cost. Let's start with a liquid-based activity. So we learned that we learned that in liquid-based activity, it's just a flat fee per ride. So how do we represent this data?
So again, it's going to be an int
Where am I writing this? Give me a line.
in the liquid-based activity, and since it's a different method, we just have to add that. Where do we need to add that in this class?
Yes, that's a great question. So first of all, it needs to, I would say, we'll eventually have it as a method because we are promising to have the method. So we can start with the method. And we know for iTheme Park activity to have access to it, what should it be?
It should be a public.
Yes, exactly. So it's going to be a public method, and it's going to be the same name as what we have promised in the theme park. So it's going to be get insurance costs. It's actually, sorry, it's an int, get insurance costs. And it doesn't take in anything, but we've promised that it's going to be an integer, so it needs to be returning something. What should it return?
Exactly. It will return this.insurance cost.
If we say this.insurance cost, what's the problem?
We have not defined the insurance cost in this class.
Exactly. We haven't defined the field insurance cost. So all we need to do is just add it in here. So let's say int insurance cost flat fee for liquid based activity. Now it depends. If every liquid based activity has a different insurance cost, we can pass it in here. Right? Like we can take in a different insurance cost flat fee. If it doesn't, if it can just be $10, then we can just use $10. But for the time being, let's say every liquid-based activity has a different flat fee. So we just say, int insurance cost, and this dot insurance cost, sure enough, gets insurance cost. Does this make sense?
Yes, makes sense. We need to add this method to other two classes.
Exactly. Are we done here?
We didn't do the testing yet.
Exactly. We haven't tested it yet. So let's test this. Actually, I don't know if this is going to create a new file or if it's going to... yes. See, so we've already created a file for liquid-based activity test, but we just want to test get insurance cost. And it says, hey, do you want to update existing class? So I do want to update existing class. If I can go to it. There we go. Okay, we already have the get name test. So I just need to do this one. All right, how do we test it?
So it's in the liquid-based activity class.
Yep, let's just start it with as an iTheme. And let's say it's going to be Chocolate Falls again.
It's new liquid-based activity.
Yep. The name is Chocolate Falls. What else does it need?
And then it needs the cost itself.
The flat rate that we just gave it, right? So let's say $10.
Yeah.
And we actually need to pass that in here as well because All right. Now how do I test it?
Assert equals
Mm-hmm.
chocolate fall.
Mm-hmm.
Let's get name. No, that gets interest cost. Excuse me.
Yes, exactly. And what should it be?
It should be 10.
Exactly. One thing I'm realizing, we didn't add comments. And now 10 is meaningless. What is 10? Is it 10 yen? Is it 10 Czech crowns? What should it be?
Let's write that as comments.
Yes, exactly. Let's say it's going to be in US dollars. Does that make sense?
Yes, totally.
Excellent. All right. We have now tested this and we can run this, but I'm sure it will pass because we're amazing programmers. What do we need to do in the other ones? Let's see. For free solo rides, it's going to be the fear factor times insurance fee. What do I need to change in the free solo rides?
So we'll need to add the fear factor.
Ooh, 1 second. Oh, it can't run that test because we haven't made the right changes to free solo rides and roller coaster, so it doesn't know how to run the program yet. So let's add those before we can run those tests. All right, what do we add here?
So we'll add a fear factor.
Excellent. Let's add a fear factor. It's going to be an int. Okay.
And then we can write here it's out of 10, let's say.
What do you mean?
I mean, we put that as a comment, so we'll not get confused later.
Oh, okay. Perfect. On scale 1 to 10. 10 being the scariest.
Sure.
Okay. Great comment. Fantastic. All right. What else?
And then we'll need to design a method to multiply the fear factor by the insurance fee. But we don't have the insurance fee here yet.
Excellent. So what should we do?
So we'll add the insurance fee too.
Okay.
In the constructors, we didn't add these information yet.
Yes, exactly. All right. Now what do we do?
So now we design the method.
Excellent. What's the name of our method? What should we write?
Let's say it will be the total cost, maybe.
Yeah. Excellent. Okay.
And it's going to be a double number, let's say.
Okay. So what do I write?
How do you write it?
Yeah. What do I write here now? Or are you asking me or are you answering? Sorry.
I just asked you.
Oh, okay. So we follow the design recipe. We start first with a purpose statement. And we say it's going to calculate this. Oh. Okay. All right. This roller coaster's insurance cost. All right. Then we go with the signature. So what's the output?
It's a double number.
Did we promise a double?
No, there are two both ints, so it will be an int eventually.
And we also promised an int. So it needs to be an int.
It has to be an int, right?
Yeah, exactly. Everything has to match this precisely. Otherwise, it's not the
Okay.
same. Okay, so it's an int, and the name has to match this exactly. So it's got insurance cost. Oh, whoops. I was trying to copy and instead I pasted. Okay. All right, and it doesn't take in anything. What else does it need to be able to be accessed on the on our interface?
So we'll need to return the cost, right?
We do, but right now this method is only accessible from roller
Oh,
coaster.
yeah. It needs to be public.
Exactly, it needs to be public. Then the next step is to actually go for an example. So in our bungee jumping, or sorry, the train example um, of, fear factor, let's say 3, and the insurance fee of 20, let's say, we expect this method to return how much?
60.
Exactly, we expect it to be 3 times 20. All right, then we go ahead with the code. So we're going to expect a return. What are we returning?
This dot fear factor times the insurance fee. This dot insurance fee.
That's exactly right. And we don't forget the R in return. And then we're done. Does that make sense?
Let's test it. Yes.
There we go. We got to test it. That's right. Let's test it up. Test it up. Oh, we didn't even test the get name before, but that's okay. All right. How do I create a new example?
So let's say I theme park activity.
I theme park activity.
What was it? It was
It's a high-speed gossip train.
Gossip trains. Yeah. It's new roller coaster.
Yep. It's a high-speed gossip train. We said it's not that scary. It's only a 3. And we said the insurance fee is a 20. All right, how do I test it?
Right, and here again we can write roller coaster. Gossip train gets new roller coaster and these informations again. Do we need to write these?
No, we can just have it as an iTheme park activity.
Okay, so for testing it, we'll use the assert equals.
Okay. Assert equals.
Roller coaster that's gets insurance.
Roller coaster dot. What did you say?
That gets name first.
Where are you going with this?
Oh, so we designed it to calculate the price. So roller coaster that gets insurance fee, was it called?
It is, but you're calling it on a class. We don't call it on a full class because a class is like, I don't know, like which specific roller coaster you want. Roller coaster is a category of classes.
So gossip train.
Exactly. Yes, we need to call it on a specific example of it. So gossip train dot get insurance cost. All right. And what should it be?
Should be 3 times 20.
3 times 20 is correct. Let's see if I can write it. Alrighty. And let's do it one one last time for the free solo. So if you remember, free solos are, oh, sorry. The free solo was the free fear factor times insurance. This was a max number of people times insurance. So that's okay.
Oh,
We can easily change that. So fear solo is just going to be the same thing as we wrote. So it's going to be int fear factor. It's going to be int fear factor. And we're going to create the same thing as we had. So I'm going to generate oops, I don't want to show that yet.
I think this class needs to have the insurance cost too.
Yes, it does, for sure. Do free solo, right? Okay. We'll go back to relevance news. And it needs to be actually max people. And it's actually going to be maximum of people times the insurance cost. Does that make sense?
Yes, makes sense.
Okay, now let's go to our tests. Well, this will be correct, so we don't need to worry about that. Let's worry about this guy. Maximum number of people. Yep, this is going to be fine. Well, maximum number of people is probably not going to be 3. It's going to be really sad train. Let's say 30. And then free solo rides has 2 problems. Let's see what the problems are. Probably the tests being not calling. Yeah. Okay. So bungee jumping, let's say, it has a fear factor of how scary would you say bungee jumping with koalas?
I would say it at least 7.
It's 7. It's a pretty, yeah. And what would you say the insurance cost is?
I would say it's $50.
Yeah, it's pretty expensive. It's probably $50 because koalas are probably expensive. Fear factor of 7 and insurance cost of, let's say, 50. Alrighty. Then we can add a test for, whoopsie, for get insurance cost. I'm just copying what we have before. And for theme park activity, gossip train gets new. It's a roller coaster activity, right?
Right.
So it's going to be a high-speed gossip train. What would you say the insurance fee for a gossip train is?
It's more cheaper, so it will be like $30, let's say.
Okay, and how many people can it hold?
50 people.
50 people sounds good. 50 people it will hold, and the cost is going to be, let's say, 30. And then how do I test this?
30 equals
Yep.
gossip train that gets insurance cost.
Yep, gossip train dot get insurance cost. Okay. To return, I think 50 times 30. Is that right?
Yes, but I can't see the screen.
Yeah, neither can I. All right. Does that sound right? Do you agree?
Yes, makes totally sense.
Excellent. All right, let's now run the test. Let's see. The tests are running. Yay, they passed.
2 tests passed.
Yes, so I think our roller coaster activity would also pass. And of course, our liquid based activity was already passing. All right. Does this all make sense, Irfan?
It all makes sense. It's awesome.
Perfect. I'm so glad you're able to use interfaces and classes and tie them all together and represent really complicated information. These are excellent, excellent concepts for you to learn. Thank you so much. Have a great day.
Thank you, Alex. You too.